Dear students, today we are going to discuss about Unit 13, Motion and Time. In Class 6 you have studied different types of motion. When an object moves along a straight line, it is called a straight line motion. When an object moves along a circular path, it is called a circular motion. And also you have studied about oscillatory motion. When an object moves to and fro, like the motion of a pendulum. And today in this class you are going to discuss about a straight line motion and the relation between motion and time. And an important term that you have to remember is the speed. Speed is the distance traveled by an object in unit time. Let us do an activity how speed can be calculated. Dear students, just now you have seen a video, an activity to show how speed can be calculated. I have taken a ball and rolled it from one end to another end of the pot. The distance between the two marks, as you have seen in the video, there are two sticks kept there. The distance between the two sticks is about 4 meters. And the time taken to travel the ball from one end of the stick to the other end is 3 seconds. That means to travel 4 meters, the ball took 3 seconds. Then how many seconds will it take to travel 1 meter? 4 meters in 3 seconds. That means to travel 1 meter, the ball will take about 1.3 seconds. So this 1.3 meter, it will travel in 1 second. So this 1.3 meter, it will travel in 1 second. Therefore, the speed of the object, speed of the ball is 1.3 meter per second. So meter per second is the unit we have used here to express speed. We have different units as well. When a bus travels 100 km in 1 hour, we can say the speed of the bus is 100 km per hour. If a car travels 200 km in 2 hours, we say the speed of the car is 100 km per hour. So kilometer per hour, meter per second, centimeter per second, all these are the units of speed. And as you see in the board there, it is mentioned the speed is calculated by dividing the total distance by total time. Why do we take the total distance? This is actually the value you get is the average speed. When you walk from your home to school, suppose there may be 4 or 5 kilometers. If you walk or if you ride by bicycle, a certain distance you may travel with one speed. Some other portion you may travel with a different speed. So it is inconvenient for us to say I have traveled first 1 hour 40 km per hour, second 1 hour I have traveled by bicycle 10 km per hour, then I travel by 5 km per hour. So it is inconvenient for us to say. So to overcome this difficulty, we take what we call the average speed. Average speed means total distance covered by total time. So we will get the average speed when you take the total distance by total time. And the unit of speed depends on which unit you have used to measure the distance and which unit you have used to measure the time. Here we can see meter per second. Meter per second. This means how many meters does an object travel in 1 second. Centimeter per second indicates that how many centimeters does an object travel in 1 second. Kilometer per hour indicates how many kilometers does an object travel in 1 hour. These are some of the units of speed. Now, next section we can see how speed can be represented graphically in graphs. Okay, we can start the topic. that is distance and time graphs. You can see a distance timetable. This means a table with the time and distance. Left side you can see the time 0, 1, 2, 3, 4, 5, 6, 7. Distance 0, 0. That means when starting time, when you start observing an object, when you start observing a vehicle, the starting time the object is at rest, that means 0 distance. After 1 hour the object has moved 10 km. After 2 hours it has travelled 20 km. After 3 hours it has travelled 30 km, and so on. We can see here 7 hours later the object was 70 km. Imagine this object, a moving vehicle, a car. Suppose it is a car, and then you can see after 1 hour it is at a distance of 10 km. That means the speed is 10 km per hour. And at the end of 2 hours the car has travelled 20 km. So 20 divided by 2, again 10. So 10 km per hour is the speed of the car. At the end of 3 hours the car has travelled 30 km. When you divide 30 km by 3 you get 10. This 10 km per hour is the speed of the car. That means this car always travels with the same speed. This kind of motion is called uniform motion or uniform speed. So here we can say the car is traveling with uniform speed. At the end of 7 hours journey the car has travelled 70 km. So when you divide 70 by 7, the average speed of the car is 10 km per hour. That means throughout its journey the car has travelled with a constant speed, or we can say uniform speed of 10 km per hour. Okay, now how we can represent this motion, uniform motion of this car in a graph. You can use a graph paper. Since graph paper is too small, I have made a graph paper like this with the pencil. You can, as you know, when you draw a graph like this, you will have an x-axis, horizontal line, x-axis, and a vertical line called the y-axis. And you place or you write the time along the x-axis as it written here, time along the x-axis. We have maximum 7 hours, so you can keep up to 7. 0 is the starting point. 0, 1, 2, 3, 4, 5, 6, 7 is time in hour along the x-axis. And the distance you can take the first point 10, then 20, 30, 40, 50, 60, 70 and 80 along the y-axis. This is called the distance axis. This is called time axis. So distance along the y-axis and the time along the x-axis. So x-axis is also called time axis, and y-axis is also called distance axis, distance in kilometer. Now refer the table 0 and 0. Here these both points are 0, so 0, 0 come here, put a mark here. Then 1 and 10, 1 and 10, 1 time 1, distance 10, this is the point. Then on the table we have 2 and 20, 2 and 20 come here, this point is 2 and 20. Then we have 3 and 30, 3 and 30, your meeting point is here, and you take like that. At the end you can find here 7 and 70. Then after marking all the points, first you mark all the points. It is convenient if you use a graph paper, or you can make a grid paper like this, and then you join all these dotted dots together as a straight line. This straight line is representing the graph, distance time graph of a object. So distance time graph is a straight line inclined to x-axis. Inclined to x-axis means making an angle with the x-axis. This may be 42 or 43 degree angle, or maybe 45 degree. So this is the graph showing the distance time graph. If distance time graph is a straight line, as you have seen here, the motion is called uniform motion or uniform speed. So this graph, straight line, passing through the origin of the graph. This 0, 0 mark is called origin of the graph. So this line is passing through the origin of the graph. So this graph straight line passing through origin is representing the motion of a object with the uniform speed. Now let us see how can we compare two graphs. How can we draw two graphs on a single graph paper? Thereby we can compare the motion, the speed of two objects. Okay. As you see here in this distance time table, two cars A and B. This represents the motion of two cars A and B. Car A is traveling in a different pattern than that of car B. Time 0, distance is 0. The car is in the porch. And the car starts. After 1 hour, the car travels 15 km. After 2 hours, the car travels 30 km. And so we can see at the end of 5 hours journey, the car travels 75 km. This means that every 1 hour, the car is traveling 15 km. 2 hours 30 km means in 1 hour it travels 15 km. In 3 hours it travels 45. It also means that the car travels with 15 km per hour. That means the average speed of this car is 15 km per hour. Car A travels with an average speed of 15 km per hour. Look at the table of car B. Starting time is 0. The car is in the porch. After 1 hour, the car reaches 10 km. After 2 hours, it travels 20 km. And as we see here, at the end of 5 hours journey, the car has traveled 50 km. So 50 divided by 5, 10 km per hour. 10 divided by 1, 10 km per hour. 30 divided by 3, 10 km per hour. Every time when you calculate the speed, we can see that the car is traveling with again uniform motion, uniform speed of that of 10 km per hour. That means car A travels at a speed of 15 km per hour. Car B travels at a speed of 10 km per hour. Let us see how it will be if you plot the graph A and the graph B. See here, use this table here, 1 and 0 and 0, 1 and 15. Here this car A table is written in green color. We can see this green color graph. How we draw this? As I told earlier, you make a sheet like this with a graph like a structure. X-axis, time is written, and along the y-axis, distance is mentioned. And we have here, we have to mark 15, 20, 45 all days. So we can take no problem. Start 0, 0. This table 0, 0, 0, 0 here. And 1 and 15. 1 and 15 is the midpoint. This is 10, this is 20. So midpoint is 15. So draw here, and this is 15. This is 1 and 15. Then second point is 2 and 30. This is 2 and 30 here, no problem. 2 and 30. Next is 3 and 45. 3 and 4, this is 40, this is 50. So the midpoint is 45. This is 45. 45 and 3. Then we have 4 and 60. 4 and 60. This is 60. This is 4. And then we have 5 and 75. 5 and 70. And this is 80. So midpoint is 75. It goes like this. At this point it means this is 75 and 5. So to come using a straight line, we can complete this graph starting from 0, 0 origin. At this point, this graph, green colored graph A, shows the motion of this car traveling at 15 km per hour as uniform speed. Now this violet color box, the table, car B 0, 0, after 1 hour 10 km it completes. After 2 hour journey it completes 20 km. So the average speed of this car is 10 km per hour. This is a uniform speed. This here 0 and 0 here, 0 and 0 starting from the same point. Both graphs start from same point. Next you mark 1 and 10. Here 1 and this is 10. This is the meeting point. Then 2 and 20. 2 here and 20 here. Then 3 and 30. 3 and 30 meeting point. Then 4 and 40, 4 is here and 40 here. This is the meeting point 4 and 40. Then we have 5 and 50. This 5 goes up. This 50, this is the meeting point. If you draw a straight line graph joining all these points, you see this violet color graph represents B. This is closer to x-axis, but this green color is closer to y-axis. This gives you an important point. That is, when a car travels at a faster speed, its graph will be closer to y-axis. The graph that is more closer to y-axis represent faster object. So looking at the graph, we can say which is faster, A or B. A is faster because A, the graph A is closer to y. The graph that is tending to move towards y or closer to y is faster. So this is a general concept that we can compare. If you have one more graph here or 4 graphs are there, without any doubt you can say the graph that is closer to y represents faster objects. Clear? This is how we draw. We can compare 2 graphs. We can draw 2 graphs on a same graph paper. Thereby we are able to compare the speeds of 2 objects. Okay, next one more type of graph I will show you now. You can see another type of data table, distance time table. Here at time 0 the car is in the porch representing 0 distance. After 1 hour it is found that the car has traveled 20 km. It is interesting to see after 2 hours also the car is at the same place. That means that's 20 km from the porch. After 3 hours also the car is found to be in the same place. That means the car did not travel thereafter. At the end of 4 hours also the car is at 20 km. That means the car has traveled initially 20 km from the porch and thereafter it did not move. That means 0, 0, 1, 20, 2, 20, 3 hours journey, again 20 km after 4 hours. So it did not travel actually. After 1 hour it did not move. It was at rest. So how this graph will be? Here, as I told you earlier, time is taken along the x-axis, distance along the y-axis, and we have 0, 1, 2, 3 up to 4. Up to 4 enough, so I have taken up to 5, no problem. And then we have 0 and 20 distances. I have taken here up to 40, so it's okay. This graph can be drawn. First 0 and 0, 0 and 0 is the origin. Then 1 and 20, 1 and 20 here, 1 and 20 this point. Then 2 and 20, 2 and 20, the same point here 20. Then 3 and 20, 3 and 20 here meeting point. Then 4 and 20, 4 and 20. This means the graph is a straight line parallel to x-axis. So this graph which is parallel to x-axis represents an object at rest. This also can be used to represent an object parked on a roadside. If you are asked to draw a graph of a car, a movement of a car which is parked on the roadside, this exactly represents an object parked on the roadside because it has moved a certain distance from its porch. Initially the car was at the porch. From the porch it moved a certain distance, maybe 20 or 30 km, and it stopped at the roadside. Thereafter it did not move. So this graph, a straight line graph, this is also straight line, but the difference is that this graph is parallel to the x-axis. The other graph was straight line, but it was passing through origin, straight and inclined to x-axis. Here this graph is parallel to x-axis. That means the distance between the x-axis and the graph at this point, the distance between the x-axis and the graph at this point are same. That is why it is called a parallel line. So a parallel line to the x-axis represents an object at rest. And this graph also can be used to represent a car or a vehicle parked on the roadside. So that's about the graph representing motion of an object. So next class we can discuss more about the measurement of time using different devices and other things. The remaining portion we will discuss next class. Okay then, so we can wind up here. Thank you very much.